So by looking at this picture, by looking at this picture, I will essentially just redraw this in a simpler form. And now this is no longer a class diagram, but at runtime, when we create an instance of int stack, right, we may give it a name, like we could say int stack, which we design ourselves, st, and give it a name. So at runtime, this is basically an object which has the pointer to dynamically allocated array of integers like this. Okay, and we also had another integer here which logically points to, just logically, right, just it's part of our logic, which points to the element inside this dynamically allocated array of integers, which is placed on top of the stack. So then when we have a diagram like this, we can clearly recognize that this is dynamic memory, and dynamic memory means that this is the memory allocated at runtime. Essentially, the program starts and decides how much memory it needs to allocate for a particular instance of stack. Okay, and then dynamic memory obviously is allocated by the new operator, right? So the new operator exists, and we can use it to ask the operating system, basically give us some memory, this is how much memory we want, and what it does, it returns back an address of that memory block, and our responsibility is to remember how big that block is, right? So when we went over to design a dynamic stack, another integer we stored inside the stack basically was the size of currently allocated memory, right? But internally we called it that integer a capacity. Okay, so we know at any given point, we know how big the stack is because we remember what the capacity of that thing is. And it could be, 100 integers at one time. Later on, it could become bigger. And when we keep talking about this arrangement, we said that this box, which represents at runtime this stack of integers, essentially acts as a resource manager, right? Because all it does, it essentially provides access to this block of allocated memory, and the user can use operations to essentially deposit and withdraw information out of this block. In case if we run out of space, so we are low on our capacity, what we decided to do is that internally this version of integer stack would duplicate the size of this memory and basically switch over to a new block and increase the capacity as necessary. So as a resource manager, we also decided to, discovered things, the needs for constructors or constructor operations, a destructor, which at the end of the day would essentially make sure that we deallocate this memory so that we don't leak any memory. Because remember, any memory that was allocated by new, our obligation is to deallocate it. If we did that, we need to find a way to say delete, basically delete it from memory. And so this is pretty much the set of features that we would describe as the needs for to internally properly organize a class that is a resource manager. Besides that, we also learn things such as this. Each operation gets a pointer that is described by the keyword this. And keyword this at any given time gives us access to the instance of our object in memory. So this is a pointer which any given operation can automatically use to access the actual physical location of our object in memory. And we also discussed references, right? So we discovered that oftentimes, besides pointers, we also may want to use references, and references represent a very convenient way of using indirection. For instance, we could have, so if we could have an operation that says use stack, right? And the input parameter for this operation was int stack reference st, and that specific parameter would indirectly give us access to a specific instance. So we'll also discuss references. This is what we discussed last week. We also discussed copy constructors, which were specific type of a constructor. And so this is a lot of knowledge that you realize you need to properly decide a resource manager like this. Now, if all that you were doing was just managing resources, you'd probably be spending most of your time programming those little intricate details of the resource manager class that you might need as a container of other objects, and that would be really a lot of time spent doing just that. So today I would like to give you more, an easier way to look at those things, and it's going to be a very quick introduction to so I'll just create new project, and we'll demonstrate a couple of library-based resource manager classes, which will be a vector and a string. And we actually are going to start using them extensively in our programming. So I think I switched to projects location, and my today project is, I think it's week 11 if I'm not mistaken, and week 11, this is going to be a demo project for week 11, and this is demo 1. So I'll just create this project and we will begin to discuss new things.